Thanks Kevin and welcome everyone. So just a little bit about myself. I've been working for CAST since 2003 and I started as a trainer for WYSIWYG. A couple of years later I moved to the tech support manager position, which I held until 2020 when I became the product manager for WYSIWYG as well as for our other software Vivian. This was a natural progression for me because over the course of my role as tech support manager, I spoke to many of our customers and learned about their needs and wishes. And now, as product manager, I hope to be able to fulfill at least some of these. One of the most frequently requested features, which incidentally started around the same time, was the ability for WYSIWYG to work with MVR files. We added this over the course of two releases, R46 and R47, and this is what I'm going to talk about today by essentially taking you through the lifetime of an MVR file. I'll start by reviewing the difference between MVR and GDTF so everyone has a good understanding of this, then move on to quickly look at how our sampler file starts its life in Vectorworks, export an MVR of that, import that MVR into WYSIWYG, modify it there, export it again, bring it back into Vectorworks for further changes, merge those changes back into WYSIWYG, and so on until we have a final version. Before I start though, I wanted to quickly review the differences between MVR and GDTF files. As I'm sure most of you know, MVR stands for My Virtual Rig, while GDTF stands for General Device Type Format. A GDTF file contains information about fixtures, while an MVR file contains information about the entire show. The relationship between these two file types is that GDTFs are included in MVRs, and in fact, an MVR file cannot exist without GDTFs. GDTFs can also exist and be used on their own, but this is not something I'm going to talk about today since the focus of this webinar is MVR. The idea with MVR is that an application that supports it, whether this is a visualizer, a lighting-specific CAD program, or a console, can import an MVR, make changes, and pass it to another application with changes always carrying through so everyone involved with the production is using the latest version of one master file. In most cases, this requires a wait for the update approach. In other words, if the file is being modified by somebody else, you have to wait for the new version before making your own changes. This is indeed a little bit slow, but in my opinion it does pay off at the end because, for example, once we're at the end of a string of changes, all we need to do is to start programming our show is import the same MVR file into the visualizer and console of choice, connect the two, and once that's done, the visualizer simulates the console's output without any need to patch or do anything more than perhaps set up some palettes, groups, and so on the console. This is facilitated by GDTFs that are part of the MVR, as these contain all the fixture simulation information required by the console to know how to drive the fixture, and also for the visualizer to understand how to visualize that fixture. GDTFs also contain other information about the fixture, such as the 3D model required by visualizers and CAD applications, as well as the 2D symbol required by applications which feature plot printing. I didn't get a chance to expand on what I meant by the fact that MVRs contain information about an entire production, but as you will see in just a minute, they can include everything from fixtures and their hang structures to 3D models of the stage, the set, and the venue. However, they do not carry any 2D information, so items such as text annotations or dimensions will not carry across between apps. This is by no means a shortcoming of MVR because, as part of its name implies, MVR is about the lighting rig and not the lighting plot. There's more to learn about MVR and GDTF, of course, more than I can cover in this webinar, so I strongly encourage you to watch the other webinars in this series to learn more and also to visit www.gdtfshare.com for more information. And now, without any further ado, we will jump into Vectorworks and have a look at how the MVR master file for a show might start its life. Alright, so here we are in Vectorworks. This is the preliminary design for our show. This is a new car presentation, let's call it, even though it's a relatively old car. But anyway, we have a backdrop, we have a stage with a car and a presenter on it. We have some audience seating, a couple of IMAX screens. And if I switch over to my top view, I have 3 lighting positions on stage and also some audience lighting for my show. So I'm happy with this, and I now need to pass it on to somebody using WYSIWYG so that they can maybe make some changes to the design, perhaps even start some preliminary programming. So to do that, we export the file to MVR. I'm not going to cover the use of this dialog because it's already been covered in the Vectorworks MVR webinar, but I will point out that in the fixture types section, anything that's listed in the GDTF mode column with the words DMX mode means that no GDTF profile has actually been assigned to that fixture. Anything that appears with what looks like a real fixture mode, so in the case, in the case of the Robin LED 600 wash, mode 2, in the case of the Alpha Spot QWO standard mode, those are fixtures to which GDTF profiles have been assigned. Now, in this particular case, the fixtures to which a GDTF profile has not been assigned are all traditional conventional fixtures, so a couple of strand SLs, par 64, scoops. So those do not actually need a GDTF profile, but anything else should really have a GDTF profile attached to it, as was mentioned previously. So I'm just going to click OK, save my file, and the export begins. And it completes after just a few seconds. And now we have a file that's ready to be imported into WYSIWYG. To do this, on WYSIWYG's welcome screen, I click the My Virtual Rig link in the import area, select the file that is exported, and hit open. WYSIWYG needs to do a little bit of pre-processing for this, and once it's done, we are presented with the MVR import wizard. On the first step of the wizard, in the top left corner, we have information about the file, including the file name, which if we hover over, we get the path to the file, the application that it was created with, and the internal MVR version of that application, and also the version of the MVR library which was used to create this file. In the import or merge type section, we have three options: new import, update existing assets only, and merge new and update existing assets. Because this is an import, we only have the new import option available, but if we were to do a merge, which we will do later on, then the other options would appear as well. The assets section contains the types of objects that are in the MVR file, and we can choose whether or not to import them by asset type. So for example, if we didn't care to import any fixtures into our file, we could uncheck the fixtures option. In that case, we would probably also not want focus positions, so we would uncheck that as well. And then only the truss, screens, and various other objects would import. One thing to note regarding the relationship between fixtures and focus positions is that if even one fixture in the file is linked to a focus position, that focus position must import. So that's why, in this case, because there are fixtures in this file which are linked to focus positions, we cannot uncheck the focus positions asset. Next, we have the layers section, which allows us to choose which layers to actually import by checking or unchecking the import checkboxes in the first column. Information about the layer status is also presented, as well as the layer name, and we can add tags or we can add descriptions which will appear in WYSIWYG's layer database. The status of a layer is new when we're performing a new import, meaning that that layer doesn't yet exist in the WYSIWYG file. Other layer statuses may be a symbol with a number 0 in it. This means that the layer will import if checked, but it will not contain any objects. So if you do see the 0 symbol, you might want to uncheck the import checkbox for that layer because you may not want to import an empty layer. One other thing that's important to note about the first step of the wizard is that the assets section and the layer section are in sync, meaning that if I choose not to import a layer, the assets from that layer will also not import, and therefore the assets count will decrease. So for example, if I choose to not import the audience lighting, I uncheck the import checkbox and my fixtures count decreases accordingly. Similarly, if I choose to not import the audience seating, I uncheck this layer and my object count decreases at the same time. Going the other way, let's say I didn't want to import any screens from the incoming MVR. If I uncheck the screens asset, I can see that the screens layer now changes status to 0. I do want to import the screens, so I will check that back, but I will leave the audience lighting and the audience seating layers unchecked because these are not items that I care about for my work, and then I click next. The second and last step of the import whistle allows me to select which fixture types to import and asks me to map them. When I say fixture types, I'm referring to each individual type of fixture that exists in the incoming file, not every single fixture. So as you can see in the table, we are not listing a number of Claypaky Alpha Spot QWO800. Instead, we are only listing one fixture of each of those types. Mapping is required because at this time, WYSIWYG does not have the capability to utilize GDTF files in any way. So in order for fixtures to simulate once connected to a console or in WYSIWYG's design mode, WYSIWYG's own library profile for the fixture must be used for that simulation. So whether or not GDTF profiles were linked to fixtures before the file was exported to MVR, that's at this time a little bit irrelevant to WYSIWYG because those fixtures still have to be mapped in order for WYSIWYG to be able to actually use them. Above the mapping table, there's a drop-down that lets us select individual layers to only show fixtures on that layer. So for example, if I select my fixtures automated layer, the table is filtered to only show the fixtures that are on that layer. This feature was added with large files in mind to make it easier to see fixtures when dealing with a lot of different fixture types. It is of course optional to use, but it can be useful when you have little or no information about the incoming file. For example, in this file, if I choose the fixtures LED layer, I see that the PAR64 fixtures have been placed on this layer. However, this layer is entitled Fixtures LED. I know that these fixtures are conventional fixtures, not LED fixtures, so I'm not maybe quite sure what's going on with them, but I will leave them for a second and we'll come back to them just before we finish the import wizard. So I'm going to switch back to see all the layers and I'm going to start mapping fixtures. To map a fixture, I select its row and then I click the ellipsis button in the selected fixtures column. This opens up a library browser window which allows me to select the fixture, and WYSIWYG automatically searches the library for the incoming fixture's name. In this case, it found it, so I can select the fixture, but before I click insert to map it, I have to ensure that the mode that I'm mapping to matches the incoming fixture's mode. To see what mode the incoming fixture is in, all I have to do is look at the title bar of the library browser, and this tells me that this fixture is set to standard mode, which uses 32 channels. To change the mode of the fixture, as always in WYSIWYG, I click the Options tab, and here I see that the mode that the QWO800 is set to by default in WYSIWYG is Vector. This does not match the mode that this fixture is intended to be used in. So I click and I select the standard mode. Now the mode matches, and also the number of channels that are listed for the WYSIWYG profile matches the number of channels, so I know that this is correct. Also, before I click insert, I make sure that the remember for future imports option is enabled. This option ensures that you only have to perform the mapping once, so it will be remembered the next time you import a file which contains this particular fixture in this particular mode, and you do not have to go through the mapping step again. We then click insert and the mapping is complete. Similarly, for the Robin 600 LED wash, we click the ellipsis button. WYSIWYG finds the fixture. We click the Options tab to check if the mode is correct. Once again, it is not. The WYSIWYG profile is in mode 3. The incoming fixture is in mode 2. So we click the mode drop down to change the mode. Now the mode matches, the channel count matches, so we're good. Remember for future imports is checked. We click insert and this fixture is mapped. The strand SL is next. Now, in this case, WYSIWYG happens not to find the fixture. That's not because this fixture doesn't exist in the WYSIWYG library, but simply because the way this profile's name happens to be spelled in the incoming file is different than the way in which it is spelled in WYSIWYG. So, if I simply click in the search box, delete the number 19, and hit enter, the fixture is found. Now, this is the 19 means that this is a 19-degree lens for this fixture. And on the Appearance tab, all I need to do is click to select this lens option. Once again, remember for future imports, and hit Insert. Same for the next one. search, find, select lens, insert, and the same for the last one. Select. Now for this one, the lens for the WYSIWYG profile is 36 degree by default. This is the lens that the incoming fixture is set to, so we can just hit insert. Before we move on from here, the next thing I wanted to point out is the DMX mode that these fixtures appear with. If you remember, I pointed this out when we exported the file from Vectorworks. DMX mode means that this fixture was not associated with a GDTF profile before it was exported to MVR. This is something particular to Vectorworks, and all fixtures like that will always have 3 incoming channels. This is simply the way Vectorworks chooses to export fixtures to which GDTF profiles have not been assigned. But regardless of this, once those fixtures are mapped, there's no problem with these fixtures being accurately simulated in WYSIWYG. The last fixture, as I said earlier, we'll pretend that we're not quite sure what's going on with it, what type of fixture this is supposed to be. So we are actually going to leave it unmapped. Now this is something that you typically would not do, but sometimes this is unavoidable. The most common way to get into a situation like that is if the incoming fixture happens not to have an equivalent in the current WYSIWYG library. So let's say the MVR file contains some fixture which was just released and it is not part of the WYSIWYG library. You could do one of 2 things. You could either wait to get that fixture and then go through the entire import process once more, or you could leave the fixture, that one fixture type, unmapped, continue with the import, continue to do your work in the new file that gets created, and then simply install that fixture profile once it's been sent to you by the library's development department, and then move on with your work. This means leaving a fixture unmapped, so instead of clicking to select an equivalent, we will click Finish. Now, because we left a fixture unmapped, WYSIWYG gives us the option of not proceeding with the import at this time by clicking No. That's in cases where you have a large number of incoming fixtures. You may have overlooked one. So in that case, you can just click No to stay in the wizard and map the fixture as needed. Or if you click Yes, all the unmapped fixtures will actually be replaced with placeholder fixtures. And we will see how placeholders work and what to do with them once we actually have the file imported. So I'm going to click Yes to proceed with the import. And after a little bit more processing, the import summary dialog appears, which lists all the items that were imported from the MVR file as per your selection in the wizard. On occasion, errors or warnings will appear for an import, but typically these are not ones that you have to actually worry about, except perhaps in cases where you know that something is missing from the import once that import has completed. In such cases, you would most likely contact tech support for assistance. In fact, I strongly suggest that you do, and they will work with you to resolve those errors and move on from there. You can click View Log to actually see the errors if you wish. I'm not going to do that now. Instead, I'm just going to click OK, and within another couple of seconds, the imported file appears. So let's have a look at what was actually imported and how. But before that, let's save the file as a WYSIWYG file so we don't have to go through the import again. I'm going to switch to my H-split custom tab that I created in order to make it easier to look at everything. First, I'm going to adjust my shaded view so that I can see everything better, including changing my background color to blue. Now I can see that everything that was in Vectorworks appears here, including the textured stage, the screens complete with the images, and most importantly, the fixtures and the truss. In the top pane, you can see that fixtures appear just as they did in Vectorworks, and this includes the strand SLs which were focused on the presenter or on the car. You can see that they retain their focus positions. So if I select this fixture, I can see that it is focused on the car, or this one on the presenter. In addition, if I switch to isometric view, I can see that the fixtures that were side-hung in Vectorworks are also side-hung in WYSIWYG, so this information comes across as well. One very important thing to mention at this point is that WYSIWYG, much like all other MVR-capable apps at this time, does not convert incoming truss to its own truss. The truss's 3D models are imported, so the truss structures appear the same, but this is not actual WYSIWYG truss from which fixtures can be hung. So what do the fixtures hang from? The answer is a 10 cm long pipe which is created during import, and there's of course one for each fixture. They're very hard to see, but if I select here, you can see that there's a little pipe here. I should also mention that positions that were assigned to fixtures in the MVR file get assigned to these little pipes during import. Of course, position names cannot be assigned to objects such as this truss, because this is just, again, a 3D mesh. This is not an actual hanging position. In most cases, none of this is an issue because ultimately the fixtures are at the correct locations. It may become an issue, however, in large and complex files because these are unoptimized 3D meshes which are nowhere near as efficient when it comes to performance as WYSIWYG's own truss. Therefore, if performance is a concern, the truss structures will have to be rebuilt within WYSIWYG with truss from the library. Once that's done, the fixtures can be moved to the new truss via the relocate fixtures command, and the imported meshes may be deleted. However, I do not recommend doing this until a near final or final version of the file, so we will do this a little bit later. I'm now going to switch my bottom pane to a spreadsheet, and I can immediately see that the patch, fixture ID or spot number, position name, and unit information that I added in Vectorworks have also imported. Therefore, I don't need to worry about assigning these attributes all over again, and this is one of the greatest things about MVR as far as I'm concerned. The fixtures that are left unmapped, which were therefore replaced by placeholders, also retain this information. We can see these down here. However, I mentioned earlier that unless these placeholders are eventually replaced with actual fixtures from the WYSIWYG library, it will be impossible to visualize. I promised that we would deal with these fixtures once the import is complete, so let's do that now. Let me start by scrolling my spreadsheet to the right until I find the notes column and dragging this notes column over to the left so I can see it on the same screen. The notes column is important because for fixtures that were replaced by placeholders, WYSIWYG added a note automatically which tells me what kind of fixture this placeholder replaced. Now this file has only one unmapped fixture, so this is not so relevant, but if I had more such fixtures, I could filter the spreadsheet by this column to only show a single fixture type, and therefore make it easier for me to work in the spreadsheet. Moving on, by looking at the patch column for these fixtures, I see that they only require one DMX channel, and this leads me to conclude that they were indeed intended to be traditional par64 fixtures. Therefore, I can now select them, access the edit menu, and select replace fixtures in order to replace them with generic par64s. Despite the warning that appeared, I can see that the patch, the spot number, the unit number, and so on, everything was retained by the replaced fixtures, just like every other time when this is done in WYSIWYG. The conclusion that I reached here, that these are indeed traditional par64s, was easy to draw on my own by simply looking at the information in front of me. If I had other placeholder fixtures in the file which were not so obvious, I would not hesitate to get in touch with the person who created the original file and get the necessary information that will help me to replace them so I can continue to do my work. Speaking of doing my work, I do have to make some changes to this original design in this file, but before that, I'm going to save my file and stop just for a minute to recap what we've learned so far. First and foremost, you should always strive to associate fixtures in Vectorworks, especially moving lights and all LED fixtures, with GDTF profiles before exporting to MVR. Functionally, this is irrelevant to WYSIWYG for the time being, but it does make fixture mapping easier and it will become important later on, so you may as well get used to it. When you import an MVR file into WYSIWYG, it is possible to select what types of assets to import as well as which layers to import. Assets and layers are in sync, however, so always double check your selections if you choose not to import everything. In addition, you should always strive to map incoming fixtures to their counterparts from the WYSIWYG library, or visualization will not be possible. If necessary, you can leave fixtures unmapped, but this will result in them being replaced with placeholders. Everything selected will import at the correct location, and textured objects will retain their textures. Hang structures are not converted to WYSIWYG truss, so each imported fixture will hang from its own 10 cm long pipe. If needed for performance, hang structures may be recreated with pipes and truss from the WYSIWYG library, and fixtures can then be relocated to them. Fixtures retain their location and hang orientations, along with any assigned position, unit numbers, patch and fixture ID, or spot number. Last but not least, placeholder fixtures must be replaced in order to be visualized. Back in WYSIWYG, I made the following changes to this file. I rotated the two screens, I moved the front truss closer to the edge of the stage, I added 9 Roby spider fixtures on pedestals around the back of the car, but I did not patch them, and I used the focus arc to focus the park's fixtures in order to create a backwash. I saved all this to a new file called v2.wyg, and I am now ready to export it to a new version of the MVR master file. Before I proceed with the export, however, I wanted to mention 3 important things about exporting MVR files from WYSIWYG. First, DMX universes will export in the order in which they appear in the patch shortcut bar. So in this case, universe 1 will export as 1, universe 2 will export as 2, 3 as 3, and so on. The universe's names are irrelevant, so even if I were to rename universe 1 to something else, it would still export as the first universe because it appears first in this list. Second, in order to export an MVR file, you must be in CAD Mode's wireframe tab, as this is the only tab in which this option is available. Third, only what's currently visible in CAD wireframe will actually export. So if there are things that you do not need to export, simply hide their layers or use this scene to control which layers are in view. With all that out of the way, let's actually export this file. To do so, we click the File menu, then Export, and finally MVR. WYSIWYG prompts for a save at this time because the MVR file that results from the export must be fully in sync with the WYG file. Note that you can choose to always save before exporting by checking the Do Not Show Again checkbox. Click Save and Proceed, and the export summary appears. This dialog lists everything that's going to be exported in 2 ways. Single numbers, such as for objects exported, simply count the number of entities of that type. When 2 numbers appear separated by a slash, the first is the count of items actually being exported, while the second is the total number of items of that type in the file. This can be useful when exporting more complex files, as it provides an easy way to confirm that only the items that you're intending to export actually do so. One last thing to point out is the focus positions count. This file does not contain 21 focus positions. In fact, there are only 2, one for the car and one for the presenter, which I've mentioned before. However, I used the focus arc to create the backwash with the park hands, and since MVR does not support either focus lines or focus arcs, WYSIWYG converts these to focus points for the export. Since there are 19 fixtures, the conversion results in 19 focus points, which are added to the other 2 for a total of 21. I finally click OK to proceed, and then Save to save the new MVR file, which I will then merge into the original Vectorworks file. Back in Vectorworks, I still have the start file open, so I can proceed with the merge by clicking File, Import, and then Import MVR. I select my file, click Open, and the import dialog appears. I don't need to make any changes here because I want everything to merge, so I click OK, and the merging starts. Once complete, I can see that the changes I made in WYSIWYG are reflected in Vectorworks, and this includes the addition of the 19 focus points that resulted from exporting the focus arc. If I click on one of the park hands and look at its properties, I can see that it is indeed linked to the appropriate focus point. One thing to note is that the Roby spiders I added don't appear with their fixture bodies, but as simple boxes. This is not Vectorworks' fault in any way, but a current shortcoming of WYSIWYG, as at this time, GDTF profiles that we export are not true GDTF profiles and do not include the necessary 3D model. We will address this shortcoming as soon as possible, but meanwhile there's an easy workaround for getting the correct fixture bodies, which I will demonstrate shortly. The other fixtures appear as they did in the original file because Vectorworks recognized them as having been in the file before this merge and therefore uses its own library data to display them. This is of course as it should be, and WYSIWYG does the same, as you will see shortly. I want to make some changes in this file, but before that I'm going to save it as version 2. The last few changes were fairly simple. I moved the par fixtures to the conventional fixtures layer and deleted the fixtures LED layer. I added a ramp at stage right and the stairs at stage left. With that done, I save the file as version 3 and now I'm going to export it to MVR. I now want to merge the latest changes into WYSIWYG, so with the version 2 file still open and working in CAD mode, I click File, Merge, select the version 3 MVR that I just exported from Vectorworks and click Open. After a bit of processing, WYSIWYG presents the same wizard as for import, but with the merge options enabled. The default option is to merge everything that's new in the MVR and apply any updates that were made to entities in the file. The second option is to simply update existing entities. In this case, I need to bring in the new ramp as well as the stairs, so I'm going to leave the default option selected. The assets section allows me to uncheck any new incoming assets if I wish, but in this case I want everything to merge, so I will not uncheck anything. I've also decided to bring the audience seating and lighting into the file, so I will leave those layers checked. Note that when merging, only new layers appear in the layer table. I click Next, and now I have to map the audience fixtures, which are 18-inch scoops, so I'm going to do this. I click Finish, and once processing is complete, the merge summary appears. There's more information here than in the import summary because in addition to listing what was added, updates and required updates are also listed. Required updates are ones that you have no control over, which must occur in order for the MVR file not to break. An example of such an update is the par fixtures, which I moved to a different layer. Since these fixtures were imported previously and are therefore in the current WYSIWYG file, they must move to the new layer as part of the merge. Once I click OK, the merge completes and I can see that the ramp and stairs are added. The audience items which didn't import initially are there as well, and also that the par fixtures are now in the conventionals layer. I will now save this file as version 3.wyg, and then I'm going to make two final changes before I start programming. One is to change the image on the screens, and the other is to recreate the front truss structure using WYSIWYG truss. Once I've got that truss, I will move the fixtures to it, move the truss structure to the same location as the meshes that were initially imported for this truss, and then I'm going to delete those meshes. I'm done with these changes, so this is now a truss structure made out of WYSIWYG truss, and when I switch to the shaded view, you can see the new image on the screens. I save the file as version 4, and I switch back to CAD wireframe in order to export it as the near final version of the MVR master file, which I will also call version 4. I don't consider this the final version because there is one more thing that I need to do with this file. I have to link the spider fixtures that I added to their actual GDTF profile. This will allow apps that support GDTF to display the actual fixture body, but more importantly, it will ensure that I have a proper MVR file complete with all the required GDTF profiles. As I mentioned earlier, this is extremely important. I could do this in Vectorworks, but since I'm going to use the GrandMA to run the show, I may as well import the MVR into the console and do this there. I also neglected to patch the spider fixtures, so I'm going to do that too. So here we are on the GrandMA3, where I imported the latest version of the MVR. Everything appears in the patch window, complete with patch and fixture ID information for the fixtures. The important thing to remember about working with WYSIWYG-exported MVRs on the GrandMA3 is that as a result of WYSIWYG not being able to export true GDTFs at this time, before any programming can begin, the exported moving lights and LED fixtures must be replaced with their true GDTF profiles, and, in the case of conventional fixtures, with dimmers. To do this, I start by selecting the fixtures that I want to replace via the fixture type column, and then I right-click. In the window that appears, I click the GDTF Share tab in order to access the GDTF repository, and then I search for the spider fixture. Once found, I expand it in order to select the correct mode, which in this case is 5, and then I click Select to complete the replacement. I also need to patch these fixtures and assign fixture IDs to them, so I do that now, and then I repeat the replacement procedure for the other movers. The replacement procedure for conventional fixtures is the same, but as I said, these must be replaced with the GrandMA3's dimmer device, which is found in the GrandMA3 library, not in the GDTF share. Once this is done, I close the patch window, save the patch, and then also save my GrandMA3 show file. The fixtures now appear in the fixture window, so I can select them, turn them on, and start programming. I probably don't need to say this, but if you get to this point and you don't see all the fixtures that you expected to see in the fixture window, this is because the ones you can't see were not replaced. So you have to go back to the patch screen and replace them there. In order to start programming the show while connected to a visualizer, I must export the final version of the MVR from the GrandMA3 and merge it into that visualizer. I consider this the final version now because it contains true GDTF profiles for automated fixtures as well as the latest patch information. To wrap things up, I can now merge the final MVR into Vectorworks and WYSIWYG, or I can import it into any other MVR capable app such as Capture, which I've done here as a quick example. Back in WYSIWYG for the last time, when I merge the final MVR into the version 4 WYSIWYG file, I choose the Update Existing Assets Only option because all I need from this version of the MVR is the updated fixture information. There are of course no fixtures to map in this case, so I click Finish and wait for the merge to complete. If I switch to shaded view, I notice that objects such as the screens and the stage are no longer textured. This happened while the final MVR was exported from the current version of GrandMA on PC, but it is easy to fix. For example, I can select the screen objects, access their properties, switch to the Appearance tab, look for the one element which is set to an image source, change this to the screen's image source, and click OK. Last but not least, I save this as the final WYSIWYG file, after which I can simply connect to my console and start programming. So to recap, you can only export an MVR from WYSIWYG while working in CAD mode's wireframe tab, and only what's currently visible is exported. DMX universes export in the order in which they appear in the Patch Shortcuts tab, regardless of their name. Since WYSIWYG does not export true GDTF profiles at this time, these must be added to the MVR file using either Vectorworks or the GrandMA. When it comes to merging a new version of an MVR into a WYSIWYG file which started from a previous version of that MVR, you can either merge new entities and update existing ones, or only update existing ones. When merging, you have control over some of the entities being merged, but there will almost always be some which must merge as a result of updates in the MVR. This brings us to the end of the webinar, but before I close, I wanted to reiterate 3 key points about working with MVR files in WYSIWYG and collaborating with other MVR-compatible apps out there. First and foremost, always ensure that GDTF profiles are associated with all the automated and LED fixtures in your file. This is not necessary from the beginning, but should be done as soon as possible. Second, for the time being, WYSIWYG does not output true GDTF profiles when exporting to MVR. Therefore, after you export such a file, you must add GDTF profiles to the MVR once more and link them to the fixtures. Again, we hope to resolve this as soon as possible. Lastly, as I mentioned at the beginning, different parties involved with the production will, at times, have to wait while someone else is updating the master MVR file for the show. However, in my opinion, the benefits of having a file which can be used by so many different departments and so many different people without having to repeat any work by far outweigh the potential inconvenience caused by the waiting. Thank you so much for joining me, everybody. Before I open it up to questions, I wanted to mention that all the files I used here are available for download via the link in the reminder email that you received earlier today. I also included a PDF document that contains a flowchart which I hope will help you better understand the lifetime of an MVR file. Should you require assistance with MVR or have any other related questions, please don't hesitate to contact me via CAST tech support email address, which is techsupport@cast-soft.com. I'm now going to pass it back to Kevin. Thank you again.